Hey guys, this is lesson 2.7, which is completing the square. So basically the goal of today is to learn how to solve a quadratic equation, which means an equation with an x squared term in it. I'm going to show you how to solve an easy version of an equation like that, because this is a step that we will need to know how to do in the process of completing the square. So if I had an equation, something real simple like this, to solve it, we would have to square root both sides, and that's going to undo the squared. So square rooting would leave you with x minus 3 equals plus or minus the square root of 7. And then the last step would just be to add 3. And so you would get x is equal to 3 plus or minus the square root of 7. And that would be all you could do there, because the square root of 7 doesn't reduce, and these are not like terms, so you can't technically add them together. All right, let's do another one very similar to that. So again, the first step would be to undo the squared by square rooting. And you would get plus or minus the square root of -4. And you're going to subtract 5 on each side. So I'm going to write it as -5 plus or minus the square root of -4. Now, this question has an additional step, because the square root of -4 is actually an imaginary number that's equal to 2i. So we would want to simplify that down before finishing the problem. Okay, and so the next thing that we need to talk about is factoring. I'm actually going to just go forward. Factoring a perfect square trinomial. That's what these are called. These are called perfect square trinomials. They're called perfect squares because when you factor them, the two parentheses that they factor down into are the same. Okay, so remember that regular factoring, you're looking for what times what equals 9. That adds up to the middle term. So what times what equals 9? That adds up to 6. That would be 3 times 3 equals 9, because 3 plus 3 also equals 6. And we could make them both negative to make the -6 in the middle. So we call this a perfect square because these three terms here factor down into x minus 3 times itself, which we could write as x minus 3 squared. Same thing over here. So what times what equals 169? That adds up to 26. Well, 13 times 13 is 169, and 13 plus 13 is 26. And since these parentheses match here, you could write it as r plus 13 squared. Okay, so the idea behind completing the square is I would like to make this a perfect square trinomial, meaning so that it turns into something that I can factor into a quantity squared, like x plus something times itself. So there's a little bit of a procedure, like kind of a trick, I guess, to do that. The trick is you would take half of this middle term, which is 1, and you're going to square that number, and that'll tell you the third value that you need to make this a perfect square trinomial. So if I have a 1 in this place, then x plus 1 quantity squared would be the correct factorization of that trinomial. So it's just a little trick, okay? So it's the same thing every time. To find a value that would go in this place that makes this a perfect square trinomial, you take half of the middle term and you square that value, and now you have a perfect square trinomial. Again, the reason behind doing this is that we want to create something. We want to create 3 terms that factor into a perfect square, okay? Because if something factors into a perfect square, it's going to be much easier for us to use when we're doing solving an equation or something. Let's keep trying. So what would this be? So we're going to do half the middle term, and we're going to square that value, and that will give you 16. And then let's see what this would factor down to. So we're looking for what times what equals 16. That adds up to 8. 4 times 4 equals 16, and 4 plus 4 equals 8. So y plus 4 times itself, or squared, would give you the correct factorization. Okay, here's a few that you can try. Why don't you try these on your own, and then I'm going to post the answers with the PDF of the answer so you can check your work there. Okay, so how does completing the square actually work when you're solving an equation? So the goal is to solve and get x equals whatever. Okay, that's the end goal. In order to do that, you're going to use completing the square. So step 1 is recognize that this is not a perfect square trinomial because there's nothing times itself that equals 3. So we're going to move the 3 out of the way, meaning put it on the other side of the equation. And we're going to put a number in its place that makes this a perfect square trinomial. Okay? So the number that's going to go in the place of the 3 will be found by taking half of the middle term and squaring that value. So 9 is the number that would make this a perfect square trinomial. And we have to balance the equation back out by adding 9 on the other side too. That way you have it still equivalent to what you started with. Okay, the next step would be to factor the trinomial that you just created. So what times what equals 9? That adds up to -6. That would be -3 times -3. If you do this correctly, this will always be the same. Both parentheses will be the same. So we're going to rewrite it as x minus 3 squared. And then on the right side, the 3 plus 9, that equals 12. Okay? From here, you have one of those really easy equations that we worked on solving at the beginning of this lesson. So we would square root both sides to undo the squared. We're going to get plus or minus radical 12, and then we're going to add 3 to find x. So x is equal to 3 plus or minus the square root of 12. Now, that answer is okay, but it's not simplified because the square root of 12 can be broken down further. So this would actually be 2 radical 3. That is your answer there. Let's try another one. So pretty much the same thing here. We're going to start by recognizing that this is not a perfect square trinomial. So we're going to move that third term to the other side and leave a space to fill in a number that will be a perfect square, meaning it will be something we can factor easily. So that process is the same as before. Half the middle term and square it. So that means we want a 4 here. And we're going to balance the equation by putting a 4 on the other side as well. Okay, now if everything works out correctly, I should be able to factor this and the parentheses should match. So what times what equals 4? That adds up to 4. Well, that would be 2 and 2. But we want a -4, so we're going to make them both negative. On the right side, we are going to have +2. And then since the parentheses match, I can write this as x minus 2 quantity squared. And now we can square root both sides to solve for x. So we're going to have x minus 2 is equal to plus or minus radical 2. And then add 2 to both sides. So your final answer would be 2 plus or minus radical 2. And that one we would be finished here because the square root does not simplify any further. Your work can change a little bit if at times, because imaginary numbers could be possible. This particular question is not the same as the last two because not all the terms are on the same side. So before you do any of your completing the square, you're going to want to put all your terms on one side of the equation. And then it's going to look like the other examples. So not a perfect square because there's nothing times itself that equals 8. So we're going to move the 8 over and leave a blank space to fill in the missing value. Okay, so Half the middle term would be -2. -2 squared should be +4. So we want a +4 added to both sides. We are going to factor, and I'm going to skip a step this time because we already know that it should be squared. And I already know 2 times 2 is 4, so I know this is going to be t minus 2. The right side will be equal to -4. And then we can square root both sides to solve. So we would end up with t minus 2 is equal to plus or minus the square root of -4, add 2. Okay, and then there's one more thing that needs done in this question. The square root of -4 is actually an imaginary number. It's equal to 2i. So your answer would be 2 plus or minus 2i. Okay, one more example. Now, this one's a challenge problem for several reasons. The first being that completing the square does not work when there's a number in the front, like this 2. So the very first thing we have to do is we have to divide this entire equation by 2. Now, it's not difficult to divide by 2, but what does happen is it does create a fraction situation here. So you're going to have to deal with fractions as you work through this problem. Okay, so I need to subtract 5/2, put a blank space, and kind of go about my way. So that is the first little issue you're going to run into. The second occurs here when you go to find your third term that you need to make a perfect square. It would end up being a fraction as well. So now you're adding more fractions into the mix, which is okay. It will be fine. But just warning that that's happening. Now, the other issue is that it's hard to factor 1/4. So what times what equals 1/4 that adds up to 1? Well, the answer is 1/2. And so here's a little insider tip. If you aren't sure how to factor something, look right here in this process where you were finding this third term. This half value, half of the middle term, is always going to be the value that you need in your factorization. Okay, so that's kind of helpful to know. We need to add the fractions together, and getting a common denominator is required to do that. So this would equal -9/4. I'm going to throw that here. Now we can square root both sides. So y plus 1/2 is equal to plus or minus the square root of -9/4. And we can subtract 1/2 to solve for y. And then the last step is you do have a radical that can simplify. So that radical is actually an imaginary number. It's an imaginary number because there's a negative in the radical, but you actually can take the square root of 9/4 because you could just do the square root of 9 and the square root of 4 and make it a fraction. And so that would be square root of 9 is 3 and the square root of 4 is 2.